Thanks very much. Well, thanks for inviting me, first of all. I'm sorry I couldn't be there in person. And I'm going to share a few slides this evening on area that I work, which is hydrological research, and just to talk about how we manage and share our data in research and how that gets used beyond research. So just a very quick bit. I'm from the UK Centre for Ecology and Hydrology, whereas I'm an environmental informatics manager, so managing data is all my main focus. CEH in general is a world-leading independent research institute, so it carries out environmental science that reaches right through to impact. So we work both on our own fundamental research, but also working on building infrastructures and data sets to support the wider research community. So making sure that the environmental research in the UK and more widely is possible. And we do a lot of that through partnerships, both with government, businesses, NGOs, and more widely. So in terms of our hydrological research, again, just to reiterate, we undertake our own kind of research into floods, water resources, water quality and ecosystems. And some of that research, for example, into floods, feeds directly through to the way that flood risk is managed in the UK. So it's the science behind flood risk estimation, flood risk mapping, and similarly for water resources, science behind predicting droughts in the future and the climate change, these sorts of things. So very important areas of research and very important data. And a lot of the way that we support research, as well as do our own research, is through that provision of data. So management and provision of data is very important. So what type of data are we talking about? It's both our own data that we produce, so through long-term research monitoring. So for example, this is a network that we run of 50 soil moisture sites. So probably the biggest, most dense soil moisture networks in the world, certainly the most dense, providing information on changes in soil moisture that can lead through to insights into areas of flooding and drought, for example. And we make those sorts of measurements across lots of areas of terrestrial and freshwater science, on whether that's in biodiversity monitoring, air pollution, all sorts of things. So yeah, we obviously have to make that data accessible and make use of that data, but we also help collate existing UK environmental monitoring data, for example, from the Environment Agency, but also SEPA and Natural Resources Wales, because we're working UK-wide, and making that as accessible as possible to researchers. And the examples I've got there, as mentioned earlier, about DEFRA's Open Data Initiative, which has been fantastic and delivered with aplomb by the Environment Agency in relation to their hydrological data, which is fantastically accessible. And it's made a huge difference both to the way that we work with that data and the way that the wider research community makes use of it. So I'm going to focus on that type of data in a moment, but just to kind of recap in terms of what researchers actually want from data, they obviously want it to be accessible. They're really interested in completeness and quality control so that they know they don't have to do a lot of work on the quality of that data before making use of it in their research. They want it fully described, so there's metadata behind that to understand how to filter that data out, which data to make use of. They want it analysis ready, so whether that's data formats or whether that's end user tools, R packages, for example, to pick up and use that data, reading that data through APIs. And they also, which probably a particular aspect for the research community, want it with a DOI. So it's sitting there with long-term access for reproducibility of that research. And obviously this chimes with everybody working in data that those are essentially fair aims. So fair is the key to what we're trying to do. So yeah, back to that example where we take data from the Environment Agency and other organizations on river flows and make it accessible. So we do a huge amount of work on preparing that data, delivering it through interfaces, but also providing background technical information on the quality of that information that people can dig into. And these are used by researchers, but also by those flood consultants who are making use of this data for flood risk assessments. So all of these stations get used every time a flood risk assessment is made. And the best consultants will be digging into those stations and understanding the data that goes behind those flood risk assessments. We provide information, spatial data on the catchments, the land cover, variability, the geology in those stations and those sorts of things, so people can really understand that data. We provide an R package to pull that data through our API and allow people to directly apply hydrological analyses. And we're also providing packaged up kind of AI ready data packages of that data with a DOI that will sit there in the long term. So that's what we do at the moment, what we've been doing. We produce a huge amount of statistics on this. These are all on our website. We get 30, 40,000 downloads of files of data from our website, hundreds of thousands of calls on our API, masses of use of the website to actually go and understand that information about those monitoring sites. This is a new initiative that we're 1 year into a 5-year build, and this is, I've underlined the words research infrastructure here, so it's the Floods and Droughts Research Infrastructure. It's infrastructure funding from UKRI, and it's providing funding both to undertake new measurements in 3 catchments across the country, intensive measurements of the water cycle, but also a digital infrastructure to deliver this data. It's really focused on improving access both to that new data, but also existing hydrological data that's currently not as well accessible as that data from the EA. We're also focused on innovation, so how we take forward the management and dissemination of data from drones, cameras, video, new sources of environmental data, and supporting the research and wider community and accessing this data is important. And just an example of that, of why that's important, is an opportunity to try to gather together that data that's really important, making it fair for things like natural flood management measures, where the actual monitoring data behind the evidence is actually quite hard to access at the moment. So if we really want robust evidence, we need robust data. And the final point I'd like to make, so one of the activities we're undertaking within that program, that infrastructure, is a focus on standards, and in particular standards for sensor data interoperability. So we're looking at data models that help describe our monitoring networks, sites, the instruments that are deployed at those sites, how those instruments, the technical specifications of those, and how those produce particular data sets, so that any users of this data set can both search across the data sets using all of these aspects of the data model, but also make use of that metadata when they've got that data. They can really understand how that data was produced. So we've been working on, these are existing standards that we're implementing, and we're working across other research organizations and others, including in the past we've had discussions across government departments about standards for sensor data. And I think I'm going to leave it there, if that's okay. Yeah, please sign up for a newsletter interested in FDRI. Please feel free to get in touch with me directly if you're interested in hydrological or environmental data. Thanks very much.
Brilliant. Thank you, Matt.